Hey, Rob, nice to see you again. Do you want to do a quick round of intros and then we can start talking about the interesting stuff here?
Yeah, I'm Rob Aguchi. I'm a director of cost governance and DevOps for Prime TSR. I have responsibilities that span across DevOps, of course, architecture as well, and a little bit of quality assurance. And recently have been on a large project that has had a need for infrastructure as code. And that led us into exploring HashiCorp and Terraform, as well as some other solutions as well. But it was an interesting journey in trying to figure out the right solution based on our needs. And we landed on Terraform as a go-forward solution for that. So looking forward to talking to you today, Iman.
Nice. You're staying busy doing software development. You're managing costs. You're managing QA. That's doing everything for the software delivery lifecycle. That's awesome. So my name is Emmanuel. I work for HashiCorp. I'm a partner solution engineer here. A lot of people are very familiar with our tools. You mentioned Terraform. We are the company behind those kind of cloud journey starting and building tools like Terraform, Vault, and Console. So I work with some of our partners trying to determine how our solutions can help solve some of the challenges our customers are running into as they look towards modernizing their application development life cycles and undertaking that digital transformation. That's the kind of I'm sure it's a hot button topic in every boardroom out there. Everyone wants to be the next Facebook, the next Google, and we want to make sure we're the front runners when it comes to digital businesses. So those are the type of things our products enable, and that's what I work with our partners to help our customers achieve. So I'm excited to hear that you were able to use Terraform as a potential solution for some of the challenges your customers are running into, and can't wait to dive deeper into that to see how you got to that decision. What are some challenges along the way? What are some unique things that sets Terraform apart? So thanks for giving me the time today.
Yeah, absolutely. Absolutely.
So Terraform is, it started out as almost a solution to the problem that our co-founders, Mitchell Hashimoto and Arvind Dadgar, had back in the day. I want to say it's 2012 or so, when they were working for an ad tech company. And the problem they were running into is they wanted a solution to be able to deploy infrastructure that they needed for environments that their company was using in a fashion where it was repeatable instead of repeatedly having to go figure out manual scripts and things like that. That's where they started out. So that's where Terraform started. And today I think it's a de facto multi-cloud infrastructure as code standard. One of the key kind of differentiating factors between Terraform and a lot of other infrastructure as code tools that you hear about in the past, things like CloudFormation or Azure Arm templates, or possibly configuration management tools like Ansible and Chef. The way Terraform sets itself apart a little bit is using declarative infrastructure as code. What that means is you do not define the steps that your program needs to take to get to the infrastructure that you desire. You just write a description of it in our domain-specific language, HashiCorp configuration language, HCL. You define the infrastructure you need. Terraform itself figures out what is the order of resources that needs to be provisioned, what attributes can I take from one resource and attach to another. So we're unique in being able to do that. The other kind of unique thing that Terraform does is it enables a plan and apply workflow. And what that means is with a plan, you get a dry run that will tell you exactly what infrastructure changes are about to happen if you choose to move forward with the apply portion of the workflow. What that helps customers do is determine what changes are about to occur, if they want those changes to happen, or if there's been some misconfigurations, they can get an idea of that from the dry run and then choose to either move forward with the workflow to the apply step or not. And once you do the apply, exactly what was shown to you during the plan is what Terraform attempts to create using APIs that your infrastructure provider surfaces to Terraform. So those two, the declarative infrastructure provisioning unique to Terraform and that plan and apply workflow, those are things that have allowed us to kind of become sort of the market leader in cross-platform infrastructure as code, because that is a workflow that can be applied to infrastructure in any platform, essentially. So we're able to manage resources with cloud providers, the big three for sure, other cloud providers that your customers might be interested in, such as Polycloud, Oracle, we are able to support those as well. And then not just cloud, we're also able to manage on-prem infrastructure like vSphere, VMs, or even load balancers and firewalls. Anything that has a configuration API, Terraform can basically talk to that API and give you that declarative plan and apply driven workflow. So that's what sort of sets Terraform apart, and that's kind of why it's one of the solutions that people look to first when they're looking at modernizing the way they manage and provision infrastructure.
Yeah, you mentioned the whole plan and apply workflow. We love the idea of the plan and being able to see what Terraform is actually going to create or update or destroy prior to actually doing the apply step where it actually executes everything.
Yep.
We've run into a number of occasions where we're glad we're running the plan because we didn't really intend to do some of the things it's saying we're going to do, and it's saved us a number of times. It's it raises our comfort level of being able to run Terraform and really understand, have a good way of deciding whether we should move forward and actually do the apply or not.
Yep. That's exactly the intention behind the feature, is that you get a dry run for free and you get to find out what could potentially happen. And then, sometimes we accidentally, who hasn't made the mistake of deploying the wrong branch of production or picking the wrong version? So that dry run is kind of a quick, easy snapshot of here's the changes that are coming, and you can, opt to move forward or not. So it is definitely a powerful feature.
Yeah, absolutely. And it was one of the selling points for us too, as well, knowing that it was, the whole infrastructure as code concept was new as we were bringing it in. And, we needed to make people comfortable in doing that, bringing that solution in. And one of the things that we were actually able to show is before we actually execute anything, here's the plan step. Here's what you can see it's going to do. If you guys, for any reason, don't want us to run this, we won't run it, and we'll, go attend to whatever issues that you see. Then we'll run the plan again. If you like it, then we'll run the apply, and everything will be there.
Yep. I think you kind of mentioned it a little bit. For a lot of practitioners that are new to the concept of infrastructure as code, it can be a little alien of, or maybe in the past they've used shell scripts or other kind of automation capabilities to manage resources. But infrastructure is kind of a unique thing for some practitioners. And I think it makes sense to talk about it a little bit, why it's so important, especially in, as we shift towards the cloud and we're moving to this world of dynamic infrastructure where we're creating and destroying resources often, right? That's something you're not doing frequently in a static data center. You're not, racking and stacking things every single day. But once you move to this dynamic world of API-driven infrastructure, that's something you might be doing, every week or every day, because there's such low cost to taking out the things that you don't need and provisioning things that you do need. So maybe we can talk a little bit about what are some of the philosophical challenges that that people ran into when they were starting to think about infrastructure as code at the customer you're working with.
Yeah, one of the biggest challenges that we ran into was, culture. And like with anything new, you kind of have that, well, why are we doing this? How does this affect me? I don't know that stuff. And there's a little bit of a concern or fear, if you will, around this new thing that may have, a negative impact to the resources that are they're used to doing things a certain way.
Yep.
So from the teams that already existed, at the company, and understanding we've always done it this way. Why are we going to this infrastructure as code new way? It seems hard. It'll take too long. It'll never work. And then the big thing is, will I still have a job? Am I working myself out of a job in automating everything? So, with respect to culture, we try to, allay some of these concerns and fears and say, no, we're actually trying to help you do your jobs better, more efficiently. The idea of, manual provisioning of infrastructure is great when you need something quick, I guess, but from that scalable, sustainable, long-term process, it doesn't work. And we've all had those experiences where, we clicked the wrong button or we did something we didn't mean to. But once you get a repeatable process in place and, through the automation and showing everybody, this is what we're doing, this is how it works, here's how we're going to engage you in the process, people start coming around. It's not an overnight thing, but they start getting a little bit more comfortable. And I think that's key as a first step.
Yep.
So many other things,
Yeah.
like ownership. Who's going to own this new thing as well? Is it the traditional infrastructure team that is going to take ownership? Those that are, kind of having these initial concerns around, I don't understand this technology and the concepts are a little foreign to me. Or do we spin up a dedicated team that just, is Terraform focused and they do all this stuff for everybody? Those are some of the questions we have to answer. What roles do we actually need to, have on this team that's working on the infrastructure as code? And similar to DevOps, I don't look at it as we have these 5 people that are always doing it. It spans some different boundaries based on the areas or domains that we're looking to deal with, whether it's, the networking side of it or actually provisioning application resources as well. It does depend, but it's more than just a specific team. So trying to establish some boundaries with some sense of ownership and accountability around who's responsible for what, while still kind of paying attention to the infrastructure types, the traditional infrastructure teams, so that they're comfortable with, all of this new auto provisioning features that Terraform provides.
Right. Yep. I think you can't understate the importance of people and culture, right? You could push in all the automation, all the tools, the best and the greatest, but unless the people and the organization, the cultural, which is kind of the soul of the organization, unless it is aligned with what you're trying to do, it's hard to succeed there. So it's definitely, I think that was a great point that you're addressing their concerns, kind of help allay some of the things that they're worried about, job security and others. So that's a perfect good starting point. And I'm sure with infrastructure as code, right, there are benefits around improved quality, right? Because you declare your version configurations and you get the environment that you want according to the version configurations. ClickOps definitely doesn't scale. A human can only click so many buttons, right? But my script can modify thousands of resources in seconds. So there's definitely a scaling aspect to it a little bit. I'm sure you, as someone who helps organizations manage cost and quality, you're really excited about those things, right? And your customers are too, once they see the big picture beyond, my day-to-day work and how is it going to affect my job?
Yeah, absolutely. Because, some of the things that the benefits that Terraform brings, as with, a lot of other forms of automation, we have the ability when we're looking at that through that cost governance lens, as you brought up, we can look to scale forward, scale back infrastructure as needed, from a cost perspective, or, we can during non-peak hours use Terraform to scale back resources or even tear down, a non-production environment for the weekend or during off business hours and spin it back up before anyone gets back into work. And that'll help really greatly reduce costs. And I couldn't do that from a manual fashion. I couldn't assign 10 guys to actually click buttons and make this happen day in and day out. So Terraform does a great job, along those lines, helping us save money.
That version aspect you mentioned, I kind of brought up, right? That is what's backing that. The fact that I know exactly what I'm going to get because my configuration is stored in my version control system. And every time I run it, I will get the same exact result because it's no manual steps, right? It's exactly what I've declared is what's going to get provisioned for me. So you can safely tear down things and knowing that you will be able to bring them back up in where they'll be working. That's a very important use case. I know a lot of customers that we work with are using Terraform for provisioning and tearing down test environments, right? You mentioned you're doing kind of either daily teardowns for, people are going home, they're, no longer need these environments to be up. But test environments are another kind of interesting use case that really enable that innovation where if I need to test a feature, I don't have to consult, organization-wide to make sure I'm not stepping on anyone's toes and, my features breaking theirs. We're able to test that out. We're able to take whatever's in production, provision a smaller version of that environment using Terraform and test my features out within, takes 10, 15 minutes for me to provision the environment. I run my tests for the next hour or two, then I tear it down. And within a couple of hours, I've validated it in a live environment if my new feature is going to work. So it enables that quick experimentation, which I think we understand is sort of the core piece of innovation is to be able to test your ideas and validate if they'll work quickly. So Terraform helps make that happen a little bit once organizations adopt and scale it.
Right. And as we're talking about, some of the challenges around implementing Terraform, just along those lines of that, what does that workflow look like? And, how can we make best use of, our traditional SDLC type practices and processes to also, apply towards what we're doing in Terraform. And again, Terraform being just code, we treat it as any other code base. We have a repo, it has its life cycle. We may start developing in, against a dev environment and work it all the way up through production, along with the same or similar approval gates and checks and balances and testing along the way. But initially, it's interesting because one of our challenges that we had were, are we doing this thing fast enough? What's our lead time to actually get some of that infrastructure provisioned? And why am I waiting on you Terraform guys when I can click ops it faster, for the immediate need? And we took a step back and thought, it's okay, at least at the point of maturity that we were at initially. It's okay to start with ClickOps, fold into DevOps, and have that automation either working in parallel or even a little bit after the fact if need be, until we actually established a more solid footprint and foundational practices around infrastructure as code. So we did start out that way. We allowed teams to go into a dev environment, click their way through it with some parameters, some stipulations in doing so. And then we would join, we would have resources join the team that to actually spin up based on what they click up. We would spin up and start automating or the provisioning of that infrastructure. And then we'd be iterating through it. And by the time they were able to jump to the next environment, we would just use Terraform at that point as that jumping point for QA stage, prod, et cetera. But the initial work in dev, we have thought it's worked okay to just start with a ClickOps kind of process.
Yeah, I think that's a very prescient and smart insight there. If you take a step back, right, we think about the SDLC for the modern application today. No one in their right mind is allowing developers to go to production and make changes there, right? We know that you should never update. No one should be going to production, running applications and making code changes there. We have a defined process of, we do an automated build, we do some testing, we promote that artifact through different environments, right? Or at least that's where we're trying to get to when we start talking about DevOps and DevSecOps principles, right? We want to have verifiable, testable artifacts that we're able to promote. And that is exactly what infrastructure as code is doing. We're bringing that same exact philosophy, which we know and verified over the past several years that DevOps has been a thing. We verified that is the right way to ensure high quality applications that we're landing in production. We're bringing the same exact philosophy to infrastructure. So you mentioned this process of promoting configurations. I think in a dev environment, similar to how I wouldn't make a Git commit for every single change I make on my laptop when I'm testing things. I think it's so valid to go test out, experiment with things in a dev environment where we know we're just trying to figure out what things work, right? Once I have an environment working there, I think that you translate into a Terraform config that you can then promote into a higher environment and test things with that. I think you touched on this, and I would make sure that this as an organizational rule and a cultural thing that's followed is, maybe in dev, we allow developers to go make changes, but in any higher environment, the only way to get infrastructure provision in that is through a versioned automated process, right? Through using something like Terraform that uses infrastructure as code to create resources that we know come from a version config, because once we validate they're working, we can take that same config to the next environment. And then Terraform has the capability to, maybe we can dive into this a little bit later, of templatized environments. But Terraform has this ability to use variables so that if your configuration is generally the same across multiple environments, you can design your architecture infrastructure to be that way. Maybe it's only instance sizes that change across environments or endpoints for your database. You can take that same configuration and pass in these variables. And that way, when you take the configuration from one environment to another, you're able to customize it for that specific environment while retaining a big chunk of that version configuration that we know we validated in a lower environment and we know it works. Traffic was flowing, we got the firewalls and security groups configured correctly. That same exact thing we can take and promote, and we know when we run it in our staging environment, it's going to work there. And then before we launch it in production, we modify our variables, which can also be versioned, to scale up the VM size so we can handle the millions of customers we'll be serving, and launch that validated config in the production-like environment. That's That's, I think, a process that you would follow with software, and the same exact philosophy we're bringing to infrastructure. And that's the objective is, to have versioned managed infrastructure in production that we know works because we validated in a previous environment.
You raise another good point around the, treating it is just code, and we mentioned before, it is just code, and treating it as an application. Once we were able to actually kind of can show people, this is what we do with application code. We have a repo, we do our pull request, we commit to the, particular branch, you trigger some CI/CD process, and, the work moves environment to environment. Once we kind of aligned it with what they were already familiar with, we're saying this is the same thing, same concept, right? We have code, we have Terraform code, we got a repo for it. We're going to do the same type of thing. We're going to develop, we're going to, create pull requests. We're going to commit to a particular branch. It's going to trigger some process. It's just going to do different things. It's not going to deploy application code. It's going to provision infrastructure.
Yep.
And I think that kind of helped them understand maybe it isn't as challenging as we once thought, or as foreign as we once thought, because we do understand how it works with applications. And, we can do that the same way with Terraform. Yes, you can, right? It's just code. And the other idea of going outside of dev into the, higher environments, up through production, we do have a rule in there that we basically say we can do some of that click ops, some of that manual stuff in dev, get our infrastructure as code correct, develop all the Terraform scripts that we need, and then get it right in dev. Once we get the green light, that's how we get into our higher environments. We don't allow the click ops to go forward outside of the dev environment, because we want to make sure we start off on the right foot. We're not creating additional technical debt to have to go back and refactor or fix at a later time. We want the goodness out of the box that Terraform is going to allow us in doing so, because, and I'll probably say this multiple times throughout our conversation, environmental inconsistencies were the bane of my existence, and a lot of others, I'm sure, where, why does it work in QA? Why doesn't it work in production? What happened to our stage environment? Why are they different? And somebody would go in and click and try and make it the same or similar, bring it back into consistency. And it never stayed that way. So we've noticed just a huge increase in consistency and a lot of, reduced issues as a result of inconsistencies,
Yep.
Across the environments. And it's allowed us to work a little quicker. We know environment 1 is like environment 2, which is like environment 3, aside from certain parameters and sizing and such. But we don't have to go back and think, well, it works in dev because dev is configured this way or QA is configured that way. That's no longer part of the conversation. We love that.
Yeah, I know. I as a operator in the past, I run into issues like that too, right? Where firewall rules are different, or we've got different configurations, different version of the application, and that's causing problems. So I think this leads to an interesting pattern, especially with Terraform, of immutable infrastructure, right? What that means is, instead of going and maintaining and updating existing VMs or machines that you've launched, you launch them with automation and you never touch them manually. No one is allowed to SSH in and do any debugging. If we figure out something is wrong, we look at the logs that are flowing into our log aggregation system. We figure out what's wrong, we fix it in code and use automation to provision the next version of that environment. We validate that it works. And then what that's done for us now is, next time there's any problems, we know that we have a working configuration. We can just launch that and that will give us a working environment. And there's no, you mentioned this manual process of like figuring out why my prod is different from my dev, or, what are the inconsistencies that have happened here. That problem is just completely taken away if you commit to using infrastructure as code to always launch your infrastructure, right? And never allowing people to go in and manually make changes, because again, humans go make changes and sometimes forget to note that down in the run book. But if your automation is making changes from version configurations that you've gotten, your Git repository, your version control system, Terraform never forgets to run the script, right? That it's always going to give you the same result. So that reduces a lot of this inconsistency and results in a massive increase of quality, like you mentioned. So that's a good pattern to look at. And if you've seen, as we push into the world of containers are doing something similar. We're taking away the ability to go modify, runtime and things like that once a container is started. We want a version artifact, the container image, and we launch the runtime from it. Similar pattern we can bring into the world of if you're, as you're thinking about application modernization, if you're still running virtual machines today, infrastructure as code can bring you those benefits of immutability that you get with containers into the world of VMs too. So that's an interesting kind of pattern to look at as organizations begin to scale and look at improving quality with velocity too.
Yeah, one of the things that I like to remind people of is, ClickOps has its place. DevOps is where we're striving to be in maturing our DevOps practices, and that DevOps always wins. So what I mean by that is you can make clicks. If you have access to an environment, we'll just say dev since it's safer there. If you go in and start clicking around, that's fine. But if you don't incorporate that into the code base, just like within an application, the next time you deploy that code base, you're going to overwrite whatever those manual modifications were. And you do that enough times, people tend to realize I should update the code base first.
Yeah. Yep.
Yeah. And I freely admit that, I might go in and click, an attribute or update something just to see if it works. And then I'll run to the code and update the code and redeploy it. So we just have to remember to do that last part, update the code.
Yeah. Yep. Exactly.